There are physical separation techniques. Michael, have a seat. Michael, have a seat. And there are chemical separation techniques. Now, in the last lab, you used both. Okay? You can use chemical separation techniques to make physical separations, but the other direction doesn't work. You can't use physical separation techniques to make chemical separations. Okay?
What?
You can use physical separation techniques. You can use chemical separation techniques to make physical separations, but you can't use physical separation techniques to make chemical separations.
You mean like to break them apart?
Yeah. Or to separate them out. Okay? When we talk about separation, we're talking about those three classes of mixtures you dealt with in that last lab. Those three classes of mixtures were suspensions, colloids, and solutions. I want to look at suspensions first. So suspensions are a physical mixture. Kenny, you got to put that away. So suspensions are a physical mixture, that is to say, a heterogeneous mixture. Okay, then we can use physical separation techniques. Okay, an example of a common physical separation technique that is used for suspensions is filtration. So you filtered out some materials in the last lab. You filtered out other materials in previous labs. And usually you use filter paper, although there are other things you use as filters instead. And here we mostly use filter paper. Colloids. So remember, suspensions have particles that are greater than, depending on who's doing the defining, either greater than 1,000 nanometers or greater than 200 nanometers. Okay? And so you can use filters to separate out things that are that large. Colloids, on the other hand, have much smaller particles. Colloids are typically, this is also a heterogeneous mixture. So we can use physical separation techniques. Examples of some of these physical separation techniques include, and you used these in the last lab,
Right.
centrifugation, using a centrifuge. That's the machine back there where you put the colloid in a tube and spun it at really high rates of speed. Okay, that's a centrifuge.
Is that particle size for suspension?
No, this, yeah, this is the particle size for suspension here.
That's like a movie.
Okay.
We don't watch it. We're gonna watch it. No, we're not.
No,
We're gonna be doing work. No. Let's watch the chemistry.
Okay. Listen. Another way you can separate out colloids is with dialysis tubing. Dialysis tubing can be used to separate out the colloidal particles. And the particle size for colloidal particles, and this depends on who's deciding, but they're almost always between the size of a nanometer.
I thought you said that suspension was between 1,000 nanometers.
No, it's greater than 1,000 or greater than 200, depending on whose definition you're using.
That's what I'm saying. You said that you had 100.
I'm sorry, it should be 1,000. So between a nanometer and 1,000 nanometers, or between a nanometer and 200 nanometers. Okay, depending on whose definition it is. I think some of it's kind of in a state of flux here. That is to say, as the science gets better, the definition gets better. Okay?
Nanometer and what did you say?
You need to be taking notes, Michael. Trey. And then we come to solutions, the thing we spent the most time on in this unit. Solutions are the only true homogeneous mixtures. So these require chemical separation techniques. Take notes, please. Okay, some examples of chemical separation techniques. Evaporation. And this is typically used when you have a solid solute and a liquid solvent. Okay. Crystallization. This is also used when you have solid solutes and liquid solvents. Okay. You all know how evaporation works, I hope.
Yeah.
Crystallization works in different ways. One way you can use crystallization is when you have a mixture of or a solution of two things, and you can cool it down to a point where the solute solidifies and comes out of the solution, and that's a way to separate out the solvent from the solution, or the solute from the solvent. Distillation. Distillation is used when you have liquid solutes and liquid solvents. Okay. Distillation takes advantage of the different boiling points of two solutions that are, two liquids that are dissolved together. Distillation takes advantage of the different boiling points of two liquids that are dissolved together. With distillation, basically you're boiling a solution, and what the vapor has a higher concentration of whatever part has the lowest boiling point, and then you condense that. Takes advantage of the different boiling points of two liquids in a solution. Got it? Okay. So if you boil something that has two liquids in it, the vapor is going to be higher in concentration of the part that has the lowest boiling temperature. So you're able to get more, basically separate them to a degree. You can't separate them completely, but to a degree you separate them that way, okay? All right. And then there's something called chromatography we haven't talked about in here yet. Chromatography.
Chromatography.
And this is used for either gas or liquid solutions. So we're going to spend a little time discussing chromatography now.